Okay, let's get into it. Today we're doing a deep dive on, well, a critical tool, something used in therapeutic GI endoscopy right when things get serious. We're talking severe internal bleeding, the kind that needs stopping fast. Our mission here is to really unpack this device, how it works, the physics, the technique, maybe its limits too. It's small, but pretty mighty.
It really is right at the sharp end, isn't it? You'll see it written up formally, as the bipolar probe, sometimes multipolar probe. But if you're actually near a GI lab, you'll hear people call it the gold probe.
The gold probe, that name definitely says something.
It does. It speaks volumes, really, about how vital it is, how much they trust it when someone's bleeding out.
And the main scenario where this gold probe really shows its value, based on the sources we looked at, seems to be peptic ulcer bleeding, like really urgent cases.
Yeah, not just a minor bleed. Often it's, active hemorrhage,
Oh.
needs immediate stopping.
Okay, so how does it actually work?
Right. That brings us to the core principle. It all comes down to something called co-aptive coagulation.
Co-aptive coagulation.
Yeah, the whole thing hangs on that. The success, the patient's immediate outcome,
Yeah.
it's all about combining mechanical force and electrical energy in just the right way.
Okay, mechanical force, let's break that down. So the endoscopist has to physically push the probe against the bleeding vessel.
Exactly. Apply firm pressure, significant pressure actually, right onto the bleeder. It's a deliberate physical act to stop the flow.
Firm pressure, that sounds subjective, especially when things are, high stakes. How firm is firm?
Well, that's where this memorable little detail comes in. It helps clinicians visualize what they're aiming for. The idea is the pressure should make the two walls of the blood vessel physically touch, make them kiss each other and occlude.
Kiss each other. Okay, so you're literally pinching the vessel closed with the probe tip first.
Precisely. It's a mechanical stopgap initially, pure mechanics.
So the flow is stopped mechanically. Then what?
Then, and only after you've got that occlusion, that kissing happening, you apply the bipolar electrical current.
Ah, okay. So the pressure holds it closed, and the electricity provides the permanent seal, like welding it shut.
That's a good way to think of it.
Yeah.
Welding, yeah. The mechanical pressure is vital without it holding the walls together. Well, the electricity would just sort of char the surface blood, wouldn't seal the vessel deep down.
And the bleeding would just start right back up again.
Immediately, yeah.
Okay, so this often happens in an emergency, right? Things are probably a bit chaotic.
Yeah.
What's the holdup in getting this thing ready? It's not just sliding it down the scope, is it?
No, definitely not.
Yeah.
You've got to get the electrosurgery unit that ESU set up and switched on first. That takes a moment.
ESU, right?
Then you have to specifically select the bipolar program on that machine, and then, of course, hook the probe itself into the correct bipolar outlet.
So choosing the right program is critical. You mentioned bipolar specifically.
Absolutely critical.
Right.
Because if you accidentally chose, say, a monopolar setting, well, that sends current through the patient's body differently. You could cause massive tissue damage, even perforation. Very different physics.
Right, okay. So precision is key even in the setup. Once it is set up, probe in place, pressure applied. How do you deliver the current?
There's usually a foot pedal, typically the blue pedal on the floor. The endoscopist presses that, and it sends the charge through the probe's tip.
Gotcha. Blue pedal for bipolar. Now, about that current, you mentioned energy. What kind of power are we talking about?
Yes. And this is probably one of the most crucial safety points from the sources. For peptic ulcer bleeding, you actually do not use high wattage.
Really? That seems counterintuitive. Wouldn't you want more power for a bad bleed?
You'd think so,
Yeah.
but no. It's about avoiding disaster, really.
Hmm.
The wall of the stomach, or the duodenum, where ulcers often are, can be surprisingly thin.
Yeah.
Especially if it's already damaged by the ulcer.
Okay.
So if you hit it with high wattage, you risk burning right through the entire wall. That's called transmural injury, perforation, a catastrophe.
So you want controlled coagulation, not blasting a hole.
Exactly. Controlled is the word. That's why the power settings are kept quite low, generally somewhere between, say, 50 and 20 watts.
15 to 20, that's it.
That's usually it. That lower level current, combined with that firm, sustained pressure we talked about, holding it for several seconds, that's what seals the vessel safely and deeply. Think of it like maybe delicate soldering, not a blowtorch.
Delicate soldering. I like that analogy. That makes sense. Controlled coagulation versus injury. That's a really important takeaway. But the device isn't just about the electricity, is it? The sources mention some versatility.
That's right. It's often more than just a coagulation tool. Many of these probes have an extra channel, sometimes with a needle capability built in.
A needle, for injection.
Precisely. That channel lets a needle pass through. And the main thing you'd inject, usually before coagulation, is epinephrine.
Epinephrine, adrenaline, why do that first?
It's a prep step. Epinephrine is a potent vasoconstrictor. Injecting it right at the base of the ulcer makes the blood vessels clamp down hard. Spasm.
So it slows the bleeding way down.
Dramatically, yeah. It can turn a, scary arterial spurt into more of a manageable ooze. Buys you time.
Time to see what you're doing properly.
Exactly. Time to see the bleeding point clearly and get the probe position just right for the actual coaptive coagulation. It makes the whole process safer and more effective.
Right, hitting pause on the hemorrhage first. Makes sense. And you also mentioned irrigation, washing the area.
Yes, saline flush. You can push saline through the device too, which is vital because heavy bleeding can just obscure everything. Pool of blood, you can't see the target.
Can't seal what you can't see.
Pretty much. So flushing with saline clears the view. Better visualization means better outcomes. Simple as that.
Now about the machines, the ESUs, are they all the same? The sources mention some variations, something about an LB machine.
Yeah, that likely refers to just a standard common electrosurgery unit. Your workhorse machine that does the basics. It'll have the bipolar outlet you need.
Okay, the standard box.
But they also specifically called out Boston Scientific units as sometimes having an extra feature.
What kind of feature?
An additional dedicated outlet specifically for water irrigation, for that saline flush we were just talking about.
So what's the advantage there? Convenience.
Efficiency, mainly. With a standard setup, the nurse or tech might be manually flushing saline with a syringe through a separate channel in the scope, or using a pump. It's another step. Having that irrigation built into the ESU connection for the probe streamlines things. You might be able to coagulate and wash almost simultaneously, or switch between them faster.
And in a serious bleed, saving seconds probably matters a lot.
Every second counts in those situations, absolutely.
Okay, so we've really established the gold probe's main job, stopping those dangerous peptic ulcer bleeds. But you mentioned the sources point to other uses too, less common ones.
That's right. While ulcers are the prime target, it does get used elsewhere in the GI tract. The sources list a few secondary applications.
Like what?
Well, one is GVE, gastric antral vascular ectasia.
GV, that's the watermelon stomach, right? With all those visible stripes of blood vessels. Why use the gold probe there? Seems like a different kind of bleeding.
It is different. And honestly, for GVE, other things are usually tried first, like argon plasma coagulation APC, or maybe radiofrequency ablation, sometimes even band ligation. Those tend to be better for the broad, superficial bleeding you see in GVE.
So when would you use the gold probe for GVE?
Maybe for a specific, more prominent vessel within the GAVI area that isn't responding to APC. Or perhaps if the other tools just aren't available. But you'd need a much, much lighter touch. Less pressure, maybe even lower watts than for a deep ulcer.
A lighter touch. Okay. What else was on the list?
Let's see. The sources mentioned diverticular bleeding. That's in the colon, of course.
Right, little outpouchings in the colon wall.
Yeah, and sometimes a vessel at the base of one can bleed quite significantly. So the probe can be used there too. Also, radiation angiocasia.
That's damage from radiation therapy causing fragile blood vessels.
Exactly. Often seen in the rectum after pelvic radiation. Those can be tricky bleeds. And then there were a couple of slightly less standard terms used in the sources, dilophalation and wise bleeding.
Dilophalation. Wise bleeding. Don't recognize those textbook terms.
No, they aren't standard. Context suggests they probably refer to specific kinds of small focal bleeding points. Maybe something like a Dieulafoy's lesion, which is an unusually large artery very close to the surface, or other kinds of small, tricky-to-find vascular spots. It just shows that clinicians get creative. If they have a focal bleeder they can reach and apply pressure to, they might try the gold probe.
So it seems like it can be used in a lot of places as long as the operator knows what they're doing.
And that's the big takeaway, the crucial caveat for all these secondary uses. Success depends entirely on the endoscopist adapting their technique, learning different settings, different pressures.
What's the main thing they need to adjust for?
The thickness of the GI wall at that specific location. That's paramount.
Wall thickness. Why is that so critical?
Think about it. A peptic ulcer often forms in the stomach or duodenum, which have relatively thick, sometimes scarred walls. You can apply pretty firm pressure there, maybe use close to that 20 watts. But treating radiation angiocasia in the rectum or a diverticular bleed in the colon, that tissue is much, much thinner, more fragile.
So the risk of perforation is way higher if you use the same force or power.
Way higher. You absolutely have to back off on the pressure and likely reduce the wattage significantly. It becomes a very fine judgment call. The difference between sealing the bleed and causing a major complication really comes down to that learned tactile feel.
Okay. So, wrapping this up then, we've really dug into how this gold probe works. It's this fascinating mix of simple mechanics, the pressure, the kissing walls, and controlled electrical energy.
Exactly. That duality is key. The mechanical force creates the opportunity for the low wattage current to do its job effectively and safely. It relies heavily on the clinician's skill, not just raw power from the machine.
It really is amazing, isn't it, that stopping a potentially fatal bleed comes down to something as basic as getting two vessel walls to touch properly. It highlights how much depends on the person holding the scope, their judgment, their dexterity.
Which leads to a final thought, maybe something for you, the listener, to mull over. We've seen that the core principle, coaptive coagulation, fundamentally relies on that manual pressure, a pressure that has to be constantly adjusted based on anatomy. How thick is this specific patient's stomach wall right here, or how thin is this part of the colon?
Hmm.
So if success hinges so much on getting that pressure just right, not too little, but definitely not too much of the success we see across all these different uses from ulcers to diverticula actually boils down purely to the years and years of practice it takes for a clinician to develop that incredibly refined tactile sense, that intuitive feel for firm versus dangerously excessive pressure. It really is the definition of a skill touch, isn't it?